Hello, this is Jack Jackson. In this video, we're going to see how we can use the algebraic technique of completing the square to help us do a trigonometric substitution, allowing us to find an antiderivative, so an integration technique. So we have the integral of 1 over x squared plus 2x plus 5. So we see this quadratic polynomial in the bottom. Of course, you might try to just let u be the denominator first, but then you pretty quickly realize you don't have the stuff you need in the top to make up du. So what we're going to do is do completing the square on this. So you split off the x squared plus 2x. It already has a coefficient of 1. We take half of that x term and bring that coefficient down here. Bring down the x. Then you got x plus 1 squared. If you square that, that's x squared plus 2x, multiply and double, and then square the last term is 1. If we add 1, we have to subtract 1. Okay, so if we group these three together, it factors as this binomial squared. The negative 1 plus 5 is 4. Or, if we'd rather do it a different way, we can use our shortcut. The x-coordinate of the vertex, h, is minus b over 2a, which is setting this derivative equal to the derivative of this thing equal to 0. Will give us the same thing, so it's negative 2 over 2 times 1. So that's negative 1. So this makes this x minus negative 1 or x plus 1. To get the 4, we take the negative 1, plug it in this polynomial, right, like this. Negative 1 squared plus 2 times negative 1 plus 5. You can see that worked out there. So you square this, you get 1. 2 times negative 1 is negative 2. 1 plus negative 2 is negative 1. Plus 5 more is 4. And so that gives us the 4 there. So either way, we get to the same place, either by completing the square or the shortcut formula that we got from completing the square, or by setting the derivative equal to 0 and finding the h and then finding the appropriate k to go with that. Any way you slice it, you're going to get to this point here. So now we see this as x plus 1 squared plus 2 squared. So that's the form u squared plus a squared. And so that's the kind that we learned in our previous section to do with a trig substitution. Since it's the one with the plus, that means the hypotenuse is the square root of the u squared plus a squared. In other words, it's the square root of the x plus 1 squared plus 2 squared, which is, in other words, that's the square root of the x squared plus 2x plus 5. That's the hypotenuse. Then the legs are 2 and x plus 1. We like to put the constant on the horizontal base, and the vertical side we like to be opposite theta. That is the u, the part with the variable. So taking these two sides together here that don't involve the square root, we get x plus 1 over 2 is the tangent of theta. Solving for x, let's see, multiply by 2 and subtract 1. X is 2 tangent of theta minus 1. This is going to put it in a form that we can find dx. So dx is 2 times the derivative of tangent theta is secant square theta. Derivative that's 0, and then we have our d theta. So dx is 2 secant square theta d theta. Now, what about the square root? Well, we actually have 1 over x squared plus 2x plus 5. So 2 over the square root there is the cosine of theta, adjacent over hypotenuse. So divide both sides by 2. 1 over the square root is 1/2 of that. Well, that square root, what's under the square root, is another way of writing x squared plus 2x plus 5. So 1 over x squared plus 2x plus 5 is 1 over x plus 1 squared plus 2 squared, which is what we found up above by completing the square. And so this is the square of this guy. So we square the other side and we get 1/4 cosine square. So now when we get down to the integral, we replace this 1 over x squared plus 2x plus 5 with 1/4 cosine square of x, of theta. And then the dx we replace with 2 secant square of theta. Now in this case, the cosine square and the secant square are reciprocals, so that cancels out completely. The 2 times 1/4 is just 1/2. Bring that out front. Now the only thing we're finding an antiderivative for is d theta, or just 1 d theta. So the antiderivative is just theta. We got our 1/2 from the front, plus c for a family of antiderivatives. Now what is theta? Well, let's see here. Tangent of theta is x plus 1 over 2. So theta is the arctangent of x plus 1 over 2. And so we have that. Now, in this one here, I wanted to show you the whole technique worked out, but actually, once we got it in, once we did the completing the square, and we got it in this form right here, we could have done a simple substitution, u equals x plus 1, du is dx, and it's in the form 1 over u squared plus a squared, and we know that that is 1 over a, arctangent of u over a is 2, u is x plus 1. And so this actually works out with the simple substitution if you have this particular integration formula or antiderivative formula memorized. But we can also work this out this way. All right, here's one for you to try. It's kind of similar to the last one. Okay, see if you can try it yourself, and then we'll check it here in just a second. The integral of x squared over parentheses 3x plus, let me start over again. The integral of the fraction x squared in the numerator, the denominator is parentheses 3 plus 4x minus 4x squared, close parentheses, to the 3/2 power, and of course dx. So see if you can compute that family of antiderivatives. Do it on your own, come back when you're finished, and check your work. Press pause now. Well, it's similar to the last one. You know, the first thing to try, of course, is just to let this more complicated base be u. The problem is the du is going to be 4 minus 8x dx, and there's no way to get the top to sort of work out that way. So let's try this technique that we just did. The 3 plus 4x minus 4x squared is a quadratic polynomial. Let's go ahead and complete the square on that. So I rewrote it in order, negative 4x squared plus 4x plus 3, split the 3 off by itself, grouped the other two terms, and factored out the leading coefficient of negative 4. And so I did this. Distribute, this uses the distributive property. We could distribute back to get that original problem, and so that's equals is valid. Okay, so let's go with that. Now, we want to factor this. We actually go all the way down here to get started. We want a negative 4 parentheses plus 3. So you take half of that middle term, which is negative 1/2, that goes here. This should be x minus 1 squared. We want to add and subtract something here. So square this, you get x squared. Multiply and double, you get minus x. We made sure that worked. Square this, you get plus 1/4. You can put a plus 1/4 if you balance it with a minus 1/4. That's inside this parentheses, the outer one here, so that is correct. And then this trinomial factors is this binomial squared. We still have our minus 1/4. Distribute the negative 4. That puts the coefficient here. It's going to make this positive 1. Plus 3 is 4. So that gets us to that point. Okay. We can, another way to do it is let h be minus b over 2a, negative, the opposite of 4 over twice negative 4. Okay, 4's cancel, the negatives cancel, you're left with 1/2. Plug in h's 1/2 in this formula right here, which is what I did here. Work this out, half of 4 is 2, 1/2 squared is 1/4 times negative 4 is negative 1. 3 plus 2 is 5, minus 1 is 4. And so we get h is 1/2. So it is, the a is negative 4, so still negative 4. Parentheses x minus 1/2 quantity squared plus the k of 4. So either way, you get the same thing. I'm going to change this around just a little bit to get it in the form that I wanted to use. 4 is 2 squared, so I could write, so this is 4 squared times this square, so I'm going to put the 2 times parentheses x minus 1/2, close parentheses, all of that in parentheses, and square it. Distribute the 2. So another way to see this term right here, 4 times parentheses x minus 1/2 squared, is 2x minus 1 squared. And I'm going to leave it in that form. So now I have a squared minus u squared, and now we're going to proceed with the trig substitution. Okay, so looking here on the left, the original denominator, the original 3 plus 4x minus 4x squared, which was going to be to the 3 halves, it's basically under a square root and then cubed. That's going to be in there somewhere, okay, one of the sides. The 2 is a minus here, and the 2 is the one, 2 squares is the one that's positive, so 2's got to be hypotenuse. And then the other two sides, one of them is going to be the 2x minus 1. When you have a choice, put the constant on the horizontal, variable on the vertical. So we put the 2x minus 1 here for the u. The a is 2. Then this side is square root of a squared minus u squared. This square root, or in other words, the square root of 3 plus 4x minus 4x squared. All right, so from the picture now that we have it, let's see, if we do the 2x minus 1 over 2, that's opposite over hypotenuse, that's the sine of that angle theta. So 2x minus 1 over 2 is sine of theta. Multiply by 2, add 1. See, multiply by 2, then add 1, and divide by 2. You get x is 1/2 parentheses 2 sine theta plus 1. dx is cosine of theta then. Let's see. Okay, so we'll take the derivative of this. We still have our 1/2. Or actually, probably better to distribute the 1/2. 1/2 times 2 is 1. So it's just sine theta plus 1/2 would be a better way of writing that, perhaps. Then dx, then the derivative of sine theta is cosine theta. Derivative of the half is 0, so dx is cosine theta d theta. Now notice if you take x squared, which we also had in our original, see, we got to figure out what that is. Since we know what x is, we can square it. X squared is the square of this, which will be 1/4, parentheses 2 sine theta plus 1 quantity square. Now, we have the square root in there somewhere. Well, yeah, we have this to the 3 halves. 3 halves is like the third power and a square root. So let's do the square root first. Okay, so that square root of this thing here over the 2 is the cosine of this angle, adjacent over hypotenuse. So multiply both sides by 2 to get the, you get 2 cosine theta is the square root. Okay, so the 3 plus 4x minus 4x squared to the 3 halves is the square root of the 2 squared minus, 2x minus 1 squared to the cube to the third power. That square root is 2 cosine of theta. So we got 2 cosine theta cubed, which is 8 cosine cubed. All right, now armed with all this, we can substitute in. Okay, a little bit of work there, but let's go stay with it. X squared is 1/4 of 2 sine theta plus 1 squared. This denominator is 8 cosine cubed of theta. The dx was cosine of theta d theta. All right, let's see what we got. Well, one of those cosines cancels that to a cosine square. And let's see here. That's a 1/4 I brought out front. I bring out a 1/8. 1/4 times 1/8 is 1 over 4 times 8. 4 times 8 is 32. So that's 1/32 out front. I'm going to expand the top here and square the first, 4 sine square theta, multiply and double in the middle, plus 4 sine of theta, and then 1 square at the end is 1. And I'm going to distribute this cosine theta. So I still got the 132 out front of the whole big parentheses. So I got 4 sine square theta over cosine squared is tan square theta, d theta, plus another integral for the middle piece, 4 out front, sine of theta, let's see. I've got a sine theta over cosine theta is a tangent theta, and the 1 over cosine theta is a secant theta. So that's integral secant theta, tangent theta, d theta. And the last one's 1 over cosine square of theta, that's secant square theta. So a lot of these are easy to do. The last one's easy. The middle one's easy. The first one maybe not so much. So let's do another trig identity on it. Tangent square theta is secant square theta minus 1, Pythagorean identity. So distributing that, that's 4 secant square theta, d theta, that integral, minus the integral of just 4 d theta. All right, I'm going to combine these secant squares together. So I got 4 here and 1 here makes 5 secant square theta. We've still got this 4 secant theta tan theta, and we've still got our negative 4 integral of d theta. All right, now we can go to town here. The integral or antiderivative of d theta is just theta. The integral or antiderivative of secant theta tangent theta is secant theta. Derivative of secant theta is secant theta tangent theta. Remember? And the derivative of tangent theta is secant square theta, so the antiderivative of secant square theta is the tan theta. Still got my 5. So at this point I have 1 over 32 times parentheses negative 4 theta plus 4 secant theta plus 5 tangent of theta, close parentheses, plus c. Now we have to substitute back in. Okay, go back up to our picture here. We have theta. Well, remember, tangent of theta is going to be, let's do sine of theta. Sine of theta is 2x minus 1 over 2, which we have right there. And so theta is the arc sine of that 2x minus 1 over 2, which is what I have here. Plus, I need this 4 times the secant of that theta. Okay, secant theta is going to be 1 over cosine. So that's going to be hypotenuse over adjacent, 2 over the square root of that thing. I'm going to write it like it was originally, 3 plus 4x minus 4x squared. Okay, plus the tangent of the theta. Tangent of theta is opposite over hypotenuse, so that's going to be the 2x minus 1 over the square root. And again, instead of writing it this way, I'm going to write it the square root of that, like it was to begin with. All right, since these have the same denominator, I'm going to keep that denominator and add the numerators. 10x minus 5 plus 8 more is 10x plus 3. And I'm just going to leave it at that for this point. My final answer. It's 1 over 32 parentheses negative 4 arc sine 2x minus 1 over 2 plus 10x plus 3 over the square root of 3 plus 4x minus 4x squared plus c. So now it's time to read some of these in your textbook and try to work some homework problems. For my class this semester, we're using Larson and Edwards Calculus Early Transcendentals books, so that's section 8.4 where they go over these techniques. And look at their examples there. That'll give you some more examples to look at. And then go ahead and work the rest of the homework problems from section homework set 1.2, starting from about 24 on to the end of that set.